The sea is naturally self-cleaning because most pollution is eaten by microorganisms living in the water. But that process can be slow.
It's tourist time across the Mediterranean, but the attraction of these coastlines can be damaged at any time by shipping accidents, resulting in oil spills which are difficult to remove from the surface of the water.
Here, a cargo ship carrying hundreds of tons of diesel has hit the rocks and sunk, spilling part of the cargo. A floating barrier and boats skimming the oil off the surface of the water is the usual but imperfect response.
This technology has its limitations. The main drawback is that the floating perimeter can't prevent some oil leaking through. Also, there are always small quantities of oil that you can't recover with mechanical methods, so a thin oil film remains.
Removing leaks is hard, but waiting for microorganisms in the sea to remove them takes too long. But what if the bacteria could eat faster? That's the goal of a European research project coordinated in Greece.
The main objective of our research project is to come up with new technologies to enhance natural biodegradation carried out by microbes in the sea. We achieve that goal with a series of measures that give microbes everything necessary to eat up the oil faster.
So what exactly is needed to make removing oil spills more simple and eco-friendly?
Researchers simulate a leak to test a new method. First, they make the oil mix with water using a biodegradable spray made from fermenting vegetable oils.
Spraying the oil with surfactant doesn't make it disappear. What it's doing is breaking it up into smaller droplets, and these smaller droplets can then be attacked by the microorganisms in the environment to completely break the oil down.
There's no need to create oil-eating bacteria. They appear in the sea wherever there's an oil leak. What's needed is to help them grow faster.
Our approach is to take a sample of the polluted water from the sea, bring it to the lab and cultivate microorganisms from it. When we've grown a large biomass of oil-eating bacteria, we spray them back over the oil slicks. So we're simply accelerating the natural process of marine self-cleaning.
Finally, to stimulate the bacteria to eat, researchers supply them with phosphorus and nitrogen. They've invented new smart particles that release the nutrients precisely where they're needed in the polluted sea.
Once the bacteria are in the sea, they have nutritional needs. For example, they need phosphorus and nitrogen. So we deliver these nutrients directly to the bacteria so that they can then break down the oil more efficiently.
Bacteria digest the oil, plankton eat the bacteria, and so the food chain in the sea continues. This natural way of cleaning oil spills should become generally available in the near future.